Hi class. In this lecture, we're going to finish our study in chapter 6, talking about polynomial functions, by talking about using factoring to solve polynomial equations. Now, this lecture is a little bit long, so I'm going to go through it rather quickly. I'm going to talk about factoring, and a lot of times when I solve a problem, you'll hear me just say, oh, this factors into the following. Okay, so I've talked about in previous lectures how you factor, so I don't want to reteach that as I'm going through this. I want to concentrate on the new topics here. Okay, and then at the end of this lecture, we will move into application problems. Okay, so the thing that's really important in this lecture today is what's called the zero factor property. So I'm going to let A and B just be not real numbers. If we ever have a situation where A times B is equal to 0, well, then there's actually two possible solutions to this equation. Either the first factor, A, has to equal 0, or B, the second factor, has to equal 0. So in words, if the product of two numbers is 0, then at least one of the numbers must be 0. All right, so let's look at this. I want to solve this. Well, notice how I have something, x minus 5, times something, x plus 2, equals 0. Well, using our zero product property, right here, or zero factor property, excuse me, that either the first factor must be equal to 0 or the second factor must be equal to 0. So to solve this, you just add 5 to each side. To solve this, you subtract 2 to each side. And what we're saying here is that this equation here has two solutions. One solution is x is equal to 5. Another solution here is x is equal to negative 2. Okay, so you can check both of these, and you'll see that they satisfy the equation. Like if you plug 5 in to the equation, it solves it. If you plug 2 in for negative 2 in for x, it also solves it. Okay, so both of these numbers solve it. Okay, and it's okay to get two solutions to an equation like this. Okay, let's solve this one here. W squared minus 2w minus 8 equals 0. Well, to solve this, the first thing you have to do is you have to factor this. Okay, so this is a trinomial, so I'm looking for two numbers that multiply to negative 8, sum to negative 2, which should be 2 and minus 4. So this trinomial will factor into the product of these two binomials. Well, now I have something times something is equal to 0. So use the zero factor property. So either the first value, w plus 2, has to equal 0, or the second value, w minus 4, has to equal 0. Solve this, subtract the 2 over, solve this, add the 4 over, and you get two solutions. Okay, so you can check that both these solutions here, negative 2 and 4, satisfy the original equation. If you plug both of them in to the original equation and solve, you will see that it checks out. Okay, so it's good. We solved this by factoring. All right, this one's weird. Okay, so I'm giving you a quadratic function now. So f of x, the quadratic function f of x, is equal to x squared minus 7x plus 10. I want to find the x-intercepts. Well, the x-intercepts occur, all right, when f of x is equal to 0. So when the other variable, the x-intercepts occur when the other variable is equal to 0. So I'm just going to set this equal to 0 and solve it. All right, well, this will factor into x minus 5 times x minus 2. So I have something times something equals 0. So I have to set the two factors equal to 0 and solve them. And you see that the first solution is x is equal to 5. The second solution is x is equal to 2. So these are the two x-intercepts. So the x-intercepts are 2 comma 0 and 5 comma 0 because we're stating them as a point, all right, because x-intercepts are points. All right, you can verify this by graphing and then using the 0 on the graphing calculator to verify this. So you can see that one solution obviously was the 2, 0 that we found, and the other one was the 5, 0. All right, so let's talk about the connection between x-intercepts and solutions. So if we let f be a function, if k is a real number solution of the equation f of x is equal to 0, then k comma 0 is an x-intercept of that graph. Also, if k comma 0 is an x-intercept of the graph, then it's a solution to that equation f of x is equal to 0. All right, let's talk about some harder ones here. All right, so I want to solve this equation. This 2x squared minus 8x is equal to 5x minus 20. Well, to be able to solve this, first thing you need to always do when you're solving an equation like this is set it equal to 0. So I'm going to subtract this over, this 5x over, and I'm going to add the 20 over. All right, so now here I have this equation, 2x squared minus 13x plus 20 is equal to 0. So to solve this, I need to factor. So you can use either the trial by error method to factor here or the AC grouping method, and this will factor into 2x minus 5 times x minus 4 is equal to 0. Well, you can just see that either the 2x minus 5 is equal to 0 or the x minus 4 is equal to 0. So solving here, add the 5 over, add the 4 over, divide by 2 on this case here. So one solution is x is equal to 5 halves. The other solution here is x is equal to 4. All right, so you can verify these solutions to the equation by using your graphing calculator, obviously. Table to check this. So the inputs are y is equal to 2x squared minus 8x is equal to the output of 5x minus 20. And you'll see that, boom, this works out. Okay, that one answer is -7, or one answer for x is 5 over 2, which gives you the same y value. One answer for x is 4, gives you the same value of y. All right, let's try this one. So x plus 2 times x minus 4 is equal to 7. So while the left-hand side of the equation is factored, the right-hand side is not 0. So the first thing you need to do is you need to find the product of this. All right, so when you find the product of this, it becomes x squared minus 2x minus 8. Now you must set this equal to 0 by subtracting the 7 over. Okay, so if it wasn't equal to 0, FOIL this out, subtract the value over, get it set equal to 0. Now refactor this. So this will refactor into x minus 5 times x plus 2. And now you can just use the 0 product property and see that the two solutions are x is equal to 5 or x is equal to -3. So the trick here is get it set equal to 0. Get it set equal to 0 and then factor. All right, so again, you can see that this works out. All right, you can verify this in your calculator using the intersect button when you graph this, and it'll be fine. All right, let's try this one. This one's a little bit harder because it has fractions. So I want to solve this 1/2 t squared plus 1/3 is equal to 5/6t. Well, the first thing you want to do is clear the equation of fractions. So you multiply everything by the LCD, which is 6. So when you do that, multiplying everything by the LCD, 6 times 1/2 is 3. 6 times 1/3 is 2. 6 times 5/6 is just 5, like this. Boom, the fractions are gone. Now you just need to set this equation equal to 0 by moving the 5t over. And now factor this. It's going to factor into 3t minus 2 times t minus 1. And now you'll just apply the zero product property, or 0 factor property. So either 3t minus 2 is equal to 0, or t minus 1 is equal to 0. And you'll see that your solutions are t is equal to 2/3, or t is equal to 1 in this case. All right, let's try this one here. Finding an input and output for a quadratic function. So I've got this quadratic function, f of x is equal to x squared minus 3x minus 23. I want to find f of 5, and then I want to find x when f of x is equal to 5. So first one, find f of 5. Just plug 5 into this equation, into this function, I mean. And when you plug 5 in, you get 5 squared minus 3 times 5 minus 23. That's just equal to -13. Now when I want to find x when f of x is equal to 5, what I'm going to do is I'm going to substitute 5 in for f of x. So how am I going to solve this now? Subtract the 5 over. Now you got it equal to 0. Now you're going to factor. So this x squared minus 3x minus 28 now factors into this. So you can see by setting the two factors equal to 0, you get two solutions here. One is x is equal to 7, and one is x is equal to -4. All right, so you can verify this by plugging it in, both these values in your calculator or into the function, also your calculator, and see if they equal 5, and they do. You can also work this into your graphing calculator with a table, and indeed, it checks out. All right, so solving quadratic or cubic equations by factoring. So if an equation can be solved by factoring, we solve it by the following steps. We're going to write the equation so one side of the equation is equal to 0. We're going to factor the non-zero side of the equation. We're going to apply the zero factor property, and we're going to solve each equation that results from applying this zero factor property. All right, so let's try this one. Let's find the x-intercepts of this graph. All right, so this looks like a cubic. So to solve this and find the x-intercepts, obviously you're going to set 0 in for f of x. So to solve this, you're going to have to factor by grouping. So when you factor the first two terms and the second two terms, you get the following, and then it will fully factor into this. But now look here, x squared minus 4 looks like the difference of two squares. So that's going to factor into x plus 2 times x minus 2. And now look, you have 3 factors. Okay, and that's okay. So the zero factor property can be applied to more than 2. So you take the first factor, set it equal to 0. The second factor, set it equal to 0. The third factor equal to 0. And you'll see that in this case, all right, finding the x-intercepts here, we literally have 3 solutions to this. X is equal to -2, 2, and 5. So it has these 3 x-intercepts as listed here. And you can see this when you graph it. Right, so if you plug this into your graphing calculator and graph it, you can see the 3 different x-intercepts, then it's absolutely true. Okay, so warning just as a reminder, this expression x squared times x minus 5 minus 4 times x minus 5 equals 0 is not factored because it's a difference, not a product. So only after we factor the left-hand side of the equation can we apply this zero factor property. Remember that. Okay, so the solution set for cubic equations in one variable, it can contain 1, 2, or 3 real numbers as the x-intercepts. So just be mindful of that. The example we did were a case where it contained 3 x-intercepts. So here are cases where you can see 3, the 2, or the 1. All right, let's solve this one. So we're going to solve by graphing, actually, in this case. So I want to figure out when does x squared minus x minus 7 equal negative x squared? All right, so what we're going to do is we're going to plug this into our graphing calculator and use the intersect option. So just going to plug both the equations, or both sides of the equation, literally into the graphing calculator, 1 under y1, 1 under y2. And then what you're going to do is you're going to hit the intersect option on your graphing calculator, and you'll see that in this case it gives approximate solutions. All right, when you use the intersect option. So you can see that one is x is equal to -6.37, so around to -1.64. And the other one is 2.137, which will round to 2.14. So that works out too. All right, let's talk about a quadratic model now. So a quadratic model is a quadratic function or its graph that describes the relationship between 2 quantities in an authentic situation. So here's an example. Annual revenues of restaurants are shown in the table for various years. Okay, so let's let f of t be the annual revenue in billions of dollars, all right, of restaurants at t years since 1970. So if you look, in 1970, restaurants made 42.8 billion, and then they've gone way, way, way up. And then by 2016, they've made 782.7 billion. So the model that describes the relationship between years since 1970 and revenue is given by 1/5 t squared plus 6t plus 50. All right, so using a graphing calculator to draw the graph of the model in the same viewing window, the scatter plot as the data doesn't fit the data well. Let's predict the revenue in 2021, and let's predict when annual revenue was 85 billion. Okay, so the last question should be somewhere between 1970 and 1980. All right, so if you plug this equation into your graphing calculator, and in the same viewing model show the data, all right, you'll see that these data points represent the years since 1970 and the revenue, and indeed this equation absolutely fits the model well. All right, so predict the revenue in 2021. All right, well, that's 2021 is 51 years since 1970. So just straight up plugging that into our function. If you use your graphing calculator to solve this at this point, you'll see that in 2021, we predict revenue will be $876.5 billion. which is crazy. All right, so let's estimate when the annual revenue will be 85 billion. So we're going to substitute 85 in for t here. Going to set it equal to 0. All right, subtracting this over. You have to clear the 5. All right, so multiply everything by 5. Now you got to try to factor this. Well, this will factor into t minus 5 into t plus 35. So you're going to get two solutions. Either t is equal to 5 or t is equal to negative 35. So the inputs negative 35 and 5 represent years 1935 and 1975 respectively. So the estimate of 1935 is an example of a model breakdown, as little research would show that revenue in 1935 was much less than 85 billion, obviously. So therefore, we estimate that it was 5 years since 1970, 1975, when revenue was $85 billion. All right, let's end on this example here. So let's talk about area of rectangle objects. So the area of a rectangle is given by the formula area is equal to length times width, right? Where L is the length of the rectangle and W is the width. All right, so a person has a rectangular garden with width of 9 feet and a length of 12 feet. She plans to place mulch outside the garden to form a border of uniform width. If she has just enough mulch to cover 100 square feet of land, let's determine the width of the border. All right, so basically this is what's going on. First thing we want to do is we want to define variable. So this person has a garden 9 feet by 12 feet. And what they want to do is they want to form a nice border around it, okay? So the mulch has enough for 100 square feet. Well, this length here, okay, you have the x on each side, okay? So you're going to take x plus 12 feet plus another x gets you 2x plus 12. The length here is 9 feet plus an additional x, some unknown value, and an additional x over here. So I'm going to let x be that width of that mulch border. So I have 2x plus 12 for one side and 2x plus 9 for the other side. So I'm going to write an equation in one variable for this. So the outer rectangle, the length is 2x plus 12 and the width is 2x plus 9. So the area is equal to the length times width, or 2x plus 12 times 2x plus 9. All right, well, remember that the area of the garden inside is 12 times 9, which is 108 square feet. The area of the border is also 100 square feet. So the area of the garden plus the area of the border is equal to the area of the outer rectangle. So basically 108 plus 100 is equal to that area of the outer rectangle. And solving this equation, FOILing it out, subtracting 1 to the other side, you end up getting 0 is equal to 4x squared plus 42x minus 100. When you factor this and solve it completely, all right, I'll skip ahead to this. I'll let you do this on your own. You'll see that one solution is negative 25 over 2, or one solution is x is equal to 2. Well, the negative one doesn't make any sense, okay? So the border width can't be negative, all right? So the border width for this one has to be 2 feet. So if the border width is 2 feet, then the outer rectangle has a width of 13 feet and a length of 16 feet. Therefore, the total area of the outer rectangle, 13 times 16, does equal 208. So this checks with our calculation near the beginning of our work.